Okay, so welcome back to section 6.2. Before I go on, I'd like to note sine is invertible in quadrant 1 and quadrant 4. Cosine is invertible in quadrant 1 and quadrant 2. Okay, so if I looked at x and y, my quadrants, sine is invertible in quadrants 1 and 4, meaning all the way up and down the y-axis, and sine corresponds to the y-coordinate, whereas cosine is invertible in quadrants 1 and 2, meaning back and forth along the x-axis. And remember, cosine is the x-coordinate on the unit circle. So that's one way of remembering it. Okay, so let's consider the graphs of tangent and cotangent. Okay, so x and y coordinate axes. So remember, in this case, I'm just going to use x as my argument. So x and y is 2 pi over pardon me. So let's do pi over 2 and negative pi over 2. Because I know that tangent had asymptotes there. No, these are supposed to be vertical. And he trends uphill in reading direction and is asymptotic to his asymptotes, right? So this is a graph of y is equal to tangent of x. Okay, in order to plot the inverse function, so x and y coordinate axes, I would change this so that my vertical asymptotes are now my horizontal asymptotes. So therefore, I'm going to have positive pi over 2, negative pi over 2 on the vertical or y-axis. And these vertical asymptotes now become horizontal asymptotes. Okay, so they share the point 0, 0. That point doesn't change. Okay, but what happens if I go to the left on the graph of y equals tangent of x? I notice as x approaches negative pi over 2, y becomes negatively infinite. So I claim as y approaches negative pi over 2, x becomes negatively infinite on the inverse graph, or on the graph of the inverse. So similarly, on the graph of y equals tangent of x, as x approaches pi over 2, y becomes infinite. So I claim as x becomes infinite, y approaches pi over 2 on the inverse function. So this is the plot of y is equal to inverse tangent of x. So let's note the domain here. So the domain on which this is 1 to 1 is non-inclusive pi over 2 to pi over 2 because I cannot cross an asymptote. And notice that the range here is also non-inclusive from negative pi over 2 to pi over 2. However, the domain is all real numbers. Agreed? Okay, let's do the same thing for cotangent. So x and y coordinate axes. Where shall I put this? This here is good enough. Nope, that's pretty bad. Okay, so pi over 2 and pi. So x and y. Okay, so I know cotangent has asymptotes at 0. And at pi. And that he trends downhill in reading direction. Actually, let me make this a bit longer so we can see what happens. Okay, so let's do this in purple. So cotangent goes downhill in reading direction, like so. So this is a graph of y is equal to cotangent of x. So the inverse function, let's do so x and y. So let's have this be pi over 2, and this is pi. Okay. So we'll have a horizontal asymptote at 0 as opposed to a vertical, and a horizontal asymptote at pi as opposed to a vertical one. They shared the, okay, so if I were to swap x and y at the point pi over 2 comma 0, I'd get 0 comma pi over 2. So now it looks like on the graph of cotangent, as x approaches 0, y becomes infinite. So I claim as y approaches 0, x becomes infinite. And similarly, on cotangent, as x approaches pi, y becomes negatively infinite. So I claim as x becomes negatively infinite, y approaches pi. So this is the graph of y is equal to cotangent inverse of x. And let's note the domain here. What color shall I use? The domain here is between 0 and pi, non-inclusive, right? So 0 to pi. Can't get to 0 and pi because those are asymptotes. And that, of course, corresponds to the range over here. So the range here is between 0 and pi. And the domain of the inverse is all real numbers. Okay, so definition. So let's let y be equal to tangent of x for x, well, between negative pi over 2 and pi over 2. That's a domain there, non-inclusive. So negative pi over 2 to pi over 2. Then inverse tangent of x, that's what we're defining. So inverse tangent of x, tangent of x, inverse tangent of x denoted by y is equal to inverse tangent of x, or so alternately we can write it as arctangent, A-R-C-T-A-N of x, has domain, well, the domain of inverse tangent is all real numbers, right? Has domain all real numbers, and range between negative pi over 2 and pi over 2. That is the restricted domain of the regular function. And of course we will note that if I can write y is equal to tangent inverse of x, this is equivalent, or if and only if, x is regular tangent of y. We always want to be able to translate that out. Okay, so definition for cotangent. So definition. So let's let y be equal to cotangent of x for x between where? Oh, looks like it was between 0 and pi, right? That's a restricted domain there. So for x between 0 and pi, non-inclusive. Okay, then inverse cotangent of x, that's what we're defining. Inverse cotangent of x denoted by y is equals to cotangent inverse of x, alternately arc cotangent of x has domain. Now once again, domain is all real numbers for inverse cotangent, all real numbers, and range. So the range should be the restricted domain of the original function from 0 to pi, non-inclusive. We also want to note that if y is cotangent inverse of x, then this is equivalent to x being equal to regular cotangent of y. Okay, so let's go ahead and do some problems. So for example, evaluate the following. Okay, so number 1, let's say we have y is equal to inverse tangent of -1. Okay, so we have y is inverse tangent of -1. Well, this is if and only if -1 is regular tangent of y. Okay, so at what angle is tangent -1? Meaning sine and cosine must be the same. Remember, tangent is invertible between -pi/2 and pi/2. So I'm guessing it'll have to be negative pi/4. Because that's between -pi/2, non-inclusive, -pi/2 to pi/2, check mark. Okay, so number 2, let's say we have that y is equal to cotangent inverse of the square root of 3. Let's do a different color, shall we? How about orange? So if y is equal to cotangent inverse of the square root of 3, this is equivalent to saying the square root of 3 is equal to regular cotangent of y. Okay, so at what angle is cotangent cosine over sine, rather, positive square root of 3? Well, the cosine would have to be square root of 3 over 2, and the sine would have to be 1/2. And that happens at an angle of pi/6. Now, is that in the allowable domain for cotangent between 0 and pi? And it is. And that is between 0 and pi, non-inclusive, so we're okay with that. Check mark. Okay, number 3. Let's say we have that y is equal to tangent inverse of 0. That's a terrible 0. Okay, let's use yellow. So y is equal to tangent inverse of 0. Well, that means that 0 is equal to regular tangent of y. So at what angle is sine over cosine 0? Basically, at what angle is sine 0? Well, that's at 0. And is that between negative pi over 2 and pi over 2? It is. So we're okay with that. And last but not least, number 4. Let's say that y is equal to cotangent inverse of negative root 3 over 3. Okay, so let's do y is equal to inverse cotangent of negative root 3 over 3, which has been rationalized. So I'm going to rewrite this unrationalized, so it'll be easier, as negative 1 over root 3. So I claim that negative 1 over root 3 is equal to normal cotangent of y. So I have to ask myself, on the interval between 0 and pi, where is the angle cotangent, meaning cosine over sine, negative 1 over root 3? Well, I have to be in quadrant 2, and that's going to be at cosine is going to be, what is it going to be? Anyone? Well, do you agree that the root 3 over 2 has to be in the denominator and the 1/2 has to be in the numerator? So where is cosine 1/2 and sine root 3 over 2? That's going to be at 2 pi over 3. Agreed? And is that between 0 and pi? It is indeed. Check mark. Okay, so I think I'll stop this one here. See you in the next video.